Let's see, ladies and gentlemen. Do we have? Yeah, we got some audio. So good morning to you guys. We've been solving some trig equations. Is that right? So good. We have some trig equations to solve. Now this morning, we have what's called multiple what? Angles. So we're trying to solve for theta. And now you say, what do you mean multiple angles? What do you guys see here? See that? That says 2 theta. That doesn't say theta. So this is what we call multiple angles when you actually have to solve a trig equation that is not theta alone. All right, you guys okay with that? So now you might say, well, what do you do? Well, go about this in the same way you have, meaning solve for sine. So the first step again is going to be, like you did before, solve for sine. So you do that by adding 1 to both sides. And you now get 2 sine double theta equals 1. And we haven't solved for sine yet. Divide both sides by 2. And now you end up with sine of double theta equals what? 1/2. Here's your what? Here's your theta. So, ladies and gentlemen, this is what you do first. Again, you sign for sine what? Double theta. Now, okay, so you might say, well, I know what to do if you had just a theta. Well, I'm going to say to you guys, change your variable. I'm going to say, let this 2 theta be the variable t now. Say, let this be t. So what you'll write down now is let t be that double theta. So you're going to switch the variables. So now you get what you find that you've done before. Okay, this is the key right here. To substitute t for the double angle. Okay, this is doing a substitution now, right in here. So this is how you handle those questions here. Okay, so here's what? Here's your t. So, ladies and gentlemen, that's how you handle this. You're just going to let this be what? A different variable, a single variable like t. That's essentially what you do. And now this is everything you've done before. You might say, well, what do you mean? Well, it's special triangles here. Here's t. Sine again is what? Opposite over what? Hypotenuse. So now you have the opposite side is 1. Hypotenuse is 2. Here's 1, here's 2. T will now be, what's the angle for t? 30 degrees, or what is t equal? Pi over what? 6. All right, so you get that special triangle again. So now, remember in your process, you had to say what before, right? All students take calculus. T is pi over 6, 30 degrees. So what quadrants is sine now again? Positive, because that's a positive angle, right? Yeah, you're going to say quadrants 1 right here, and 2. All right, so you already have the first solution for t. Okay, so this is really t1. We need t2 now. So if the reference angle is, what is that, 30 degrees? So here's what we're saying now. If I can draw the arrow. Here's that reference angle again, 30 degrees, or pi over 6. How do you guys find a solution here? That second solution in quadrant 2. Do you guys remember that equation? That's going to be now pi minus the what? The reference angle here. So you get the second solution going to be for t, pi minus that pi over 6 reference angle. We've seen this over and what? Over again. So do your arithmetic now. 6 over 6 and t2 will be what? 5 pi over 6. Okay? So you got two solutions, pi over 6 and then what? 5 pi over 6. Here you go. And there it is. Easy peasy what? Lemon squeezy. What's that? No, your reference angle is your quadrant 1 angle. It's the positive solution here. It's a positive solution here. So in quadrant 1, your reference angle is that angle. So T is the reference angle. So you found here in quadrant 1 this solution to be pi over 6. So that was your quadrant 1 solution. This is your reference quadrant. It's pi over 6. That is the key for all of these questions, is to find the reference. You say, how do I find it? You find it here with this what? Sine t is 1/2. So the angle, the solution, is the reference angle. Now, but here's the problem here, ladies and gentlemen. They had sine 2 theta, and they restricted the domain to be what? 0 to 2 pi. So how, here's going to be our question now, right? Let's recall, your domain here is for theta. Theta is 0 to 2 pi. T is double theta. So now you say, what do I do? Well, they want theta. So what this means is, let's go back and find the right color, right? Let's go back and write these solutions here, right? We know t in one case is pi over 6, and t in the other case is 5 pi over 6. Okay, we're going to do now some logic. I gave you guys this logic already when we work with proofs. Here's our logic, ladies and gentlemen. If you guys remember. If A equals B and A equals C, then what do you know? B equals C. Okay, we did the J-Lo logic. Remember, J-Lo is Jennifer Lopez, and J-Lo is Jenny from the Block, so it means Jennifer Lopez is Jenny from the Block. So what I want you guys to notice is this. Here's your T, right? And in this case, T is 2 theta, And in this case, t is pi over 6. What does that actually mean? Can you guys see what I'm saying? Maybe with colors? If A is B and A is C, that means B is what? C. So that means the following. Let's go back here. We're going to use this. So what I want to say, though, let's be careful here, right? These are the two solutions that we've gotten. So let me take a step back. I got distracted here by the question here. Yeah. Okay. What I'm going to recommend you guys do is write the general solution. And with the general solution, though, with your t now, the first solution in general is going to be what? Right? Pi over 6 plus 2n pi. And the second solution will be what? 5 pi over 6 plus what? 2n pi. These were the general solutions that we worked with yesterday. Is that right? Because we had to get every coterminal solution. Okay, those are the two general solutions. Good. And then now you knew that 2 is what? 2 theta. T is 2 theta. So what that means now, in both cases, this is the same t. This means 2 theta is pi over 6 plus what? 2n pi. And it also means that 2 theta is 5 pi over 6 plus 2n pi. So notice here, here's your t. T is here, t is here, t is here. Here's the point. This is where the logic comes in here, ladies and gentlemen, with the colors here. This is my point to you. Get the general solutions here. And then substitute back for t being 2 theta, okay? What do you guys think you got to do here? Because remember, they want answers in terms of theta, not t. So does anybody know, what do you have to do now? You're going to do what? Divide both sides now by what? By your 2. And on the left here, we get what? Theta equal to pi over 6 divided by 2 plus 2n pi divided by 2. And so for that first theta, you guys remember your arithmetic? What happens when you divide by a whole number? Here the 2's cancel. You get n pi. So here you're going to write pi over 6 now times 1/2 plus that n pi. And you can get pi being what? Theta being pi over what? 12 plus n pi. So here is going to be your first what? General solution in terms of theta. All right, now you do the same for the other solution since there were 2. All right, so you say, okay, I'm going to divide both sides again by 2 here. We cancel. And the algebra, we distribute. 5 pi over 6 divided by 2. 2n pi divided by 2. Cancel your 2's. So here's what you end up with. Theta going to be what? 5 pi over 6 divided by 2 plus n pi. 5 pi over 6 times 1/2 plus n pi. And theta is going to be 5 pi over 12 plus what? N pi. Now, this is in terms of theta here, because remember, your original question was in terms of theta. This is the original question in terms of your theta, solving from multiple angles. So now, ladies and gentlemen, you might say, they gave me a restricted domain, though. Okay? You go, how do I find all the solutions between 0 and what? 2 pi. What do I do with this? What I'm going to also recommend at this point is to do what? Do what we did yesterday. Write the what? Sequential solutions. Write your sequential solutions. And so, ladies and gentlemen, how do you do this sequential? What did we do yesterday? Do you guys remember? How would we go from a general solution like this to the sequential form? What did we do yesterday? Do you guys remember? See that 12? What are you going to do? Multiply the top by 12, divide by 12. So you're going to end up with theta being pi over 12 plus 12 and pi over 12. You guys remember the process? And then what did we say yesterday? I got out the pink. Factor out your pi over 12. Factor out that term. Didn't we try that yesterday? Yes. Factor out the pi over 12. Good. Write your sequential form. You're going to be happy about that. Now you say, okay, that's pi over 12 times, you say, but is there a 1 there? I need a number. Put a 1 plus 12 in. So this becomes 1 plus 12 in, ladies and gentlemen. Here is what you want to do. And does anybody know why you want to do it this way? Why have that sequential form here? Right? Because now you have a formula. You could now do this. You say, let n be 0. Just like yesterday. If n was 0, can you guys tell me what theta will be? Plug in 0 for n. Do your arithmetic. That theta is just going to be what? Pi over 12. You're right, because 12 times 0 is what? 12 times 0 is 0, plus 1 is 1. That's just pi over 12. Now that is in the interval from 0 to what? 2 pi. Okay? That's just one solution. What do I do for another? Now use n as 1. This is why you have the sequential form. Replace n now with 1. What do you guys get for theta? Theta is now going to be what? 12 times 1 is 12, plus 1 gives you what? 13. Is that true? So that means I get 13 pi over 12 as a solution. Here's another solution. What do you think we got to do? Is that in 0 to 2 pi? Do you guys happen to know? Be careful here. Here's my point to you. Be very careful. How do I know this is between 0 and 2 pi? How do we really know? You see this ratio? 13 twelves? Isn't that like 1 point something? It's not quite 2. So it's going to be between 0 and what? 2 pi. So we're going to keep going. This is why you guys like the sequential form. This is why you want to use that. Now let n be what number? Keep going. Let n be what? 2. What is your theta going to be? If n is 2 now, What's that going to be? 2 times 12 is what? 24 plus 1 is? So this is now going to be 25 what? 25 pi over 2. And what do you guys know about this ratio here? I'm sorry, over 12. What do you guys know about that ratio? Isn't that bigger than 2? So what does that mean? Throw it out. That solution is not in your restricted domain because they want solutions where? Between 0 and 2 pi, ladies and gentlemen. So this is why you go all the way down to the sequential form. This is why you were here yesterday to study these trig equations, because now with multiple angles you have to get those solutions in that interval. It's extremely important to get those solutions. So my recommendation is do the sequential form and generate your solutions. Now, don't forget you had another one. What was the other one? 5 pi over 12 plus n pi. So with the other solution, multiply what? Top and bottom by what? 12. And what do you end up with? Okay, don't you get that? Now, what do we factor out like we did earlier? The pi over 12. You guys okay with that? Don't forget, what's left? 5 plus 12n. Good. So the sequential form now here will be theta will be what? Pi over 12 times 5 plus what? 12n. Here's your sequential form. So my recommendation is get the sequential form and do what now? Let n be your integer. Find the solution. Do your arithmetic. You say 5 pi over 12. And here is 0. What's anything times 0? 0. And then 5 plus 0 is 5. So what's your answer? 5 pi over 12. There it is, ladies and gentlemen. Easy peasy, what? Lemon squeezy. N is 0. Now let n be what? 1. So what happens when I do my arithmetic now? 5 plus 12. Because 12 times 1 is 12. What's 5 plus 12? 17. Theta is going to be what? Is that ratio here of 17 what? Over 12. Is that smaller than 2? Do you guys know? Is 17/12 smaller than 2? What if you say, I don't know, Mr. Judge? What do you guys think? Is that smaller than 2? You could do that arithmetic. 24 over 12 is 2. So 17 over 12 is smaller than 2. You say, I don't know. I got to use my calculator. Okay. We're asking you, is 17/12 that ratio smaller than 2? Sure is. It's 1.4. So, ladies and gentlemen, that means this is a solution in the restricted domain from 0 to 2 pi. Okay, easy peasy lemon squeezy. What do you do now? Let n be what? Let n be 2. Generate another solution. See if theta is there. So if n is 2, what's 12 times 2? Isn't that going to be what? 24, and then plus 5 is 29. And then you say, oh, is this 29 what? Theta is going to be 29 pi over what? 12. What do you guys know about that ratio? It's bigger than 2 because 24/12 is 2. So what that means, ladies and gentlemen, is you stop right there because you're just going to get bigger and bigger. So when you look in back of the book, ladies and gentlemen, what do you guys see as solutions? You're going to see this as your solutions. Pi over 12, 13 pi over 12, 5 pi over 12, and 17 pi over 12 as your what? Solutions. Easy peasy lemon squeezy. And that's how you do it. So when they say, hey, they give you a nice restricted domain, well, start with all the work we did with the general solution. Write the sequential form and use your integer values of n 0, 1, 2 because that restricted domain starts at 0. And now we put everything together. What do you guys think? You see how it comes together? We got to give this to you guys in bite-sized pieces. If we don't, you might choke. Do you guys know what I'm saying? All right. Let's give you guys another example of all of this here, ladies and gentlemen. Here's some examples. Did you guys notice questions like this on your homework? And you go, boy, where's that Mr. Judge at with this? How do I handle the multiple angles? He hasn't even talked about that yet. Well, I am now. Anybody notice on that homework? You're not going to do it the night before, are you? I hope not. And you go, how would this work with multiple angles? Well, let's see. What you're going to do now, you're going to notice this is multiple angles. You say, how do I know? Because there's a 3 times theta now. And again, they're going to want your solutions to be between 0 and what? 2 pi. So we're going to have to repeat this whole process. Now, maybe in the beginning, maybe you say, you know what I'm going to do? I'm going to start it off this way. Let t be 3 theta. So that I get the square root of 3 tangent of t now plus 1 equals 0. Now this is just like all the work we already did. Yes, the variable is not x or theta, it's t, but we did a substitution. We're going to let t always be what's in there. Easy peasy lemon squeezy. Do that substitution. Okay, now go through what you've already done. Solve like we did before. Solve for tangent t. So we get the following. Tangent t, subtract 1 from both sides. Remember that? So we get the square root of 3, tangent t is -1. We'll do every detail. Divide by the square root of 3 from both sides. You solve now. Tangent t now is -1 over the square root of 3. Now remember, this is going to be what again? A negative. And you go, oh, then I need the reference. Is that right? So we go through and get the reference angle. Tangent +1 square root of 3. Here's your reference. Opposite over what? Adjacent. What is the hypotenuse going to be? 2. Okay, what does the reference angle have to be in this case? Anybody know? What's the reference angle? Isn't that 30 degrees again? I know. I'm not even awake. Is that 30 degrees? Is that pi over 6? Is that true? I'm not awake. All right. Well, that's the reference angle because tangent of t is negative. So we got the positive 1 quadrant solution. Now let's bring this, all students take calculus in. What's that? This is a 30-degree angle.
I'm saying, is it consistent that the 30-degree angle is on the bottom, while 60 degrees is on the top?
Well, I'm looking at this right here. This is a 30-degree angle. If that's 30 degrees, this will be 60 degrees. That is true.
That's always, right? Like nothing changes.
Well, the 30, 60, 90 triangle that we're looking at does not change. That's correct. So this is 30 degrees. However, the real question is not where is tangent positive, where is tangent what? Negative. Which quadrants? Which quadrants have tangent being negative? Quadrant 2, is that true? And quadrant what? 4. Those are where tangent is negative. The reference is 30 or 60 degrees. So you might even say, well, what does that even look like? Well, I'm going to draw the picture for you guys here. The reason you want that 30 degree or pi over 6, this is your reference angle, right? And then the opposite quadrant over here. (30 degrees), which is what? Pi over 6. So remember what you want to do. You want to get t. You're only going to have one general solution. You want to write this general solution. Is that true? Do you guys know what I'm saying? So what is the general solution here? You start with this one here, over here, right? How do you get that solution? That's going to be pi minus the reference. And so doing your arithmetic again, this isn't that 6 over 6? So what angle is that? That's going to be what? 5 pi over 6. Is that true? So we got this solution here. Do I even need to write down the other solution? I'm writing the general solution, ladies and gentlemen. You guys have been working on this. Hopefully you know. What do I do now to get, do I even write down the other? Or I just say what? That's plus n pi. Good. And that's it, ladies and gentlemen. This is your what? General solution. Because that differs by pi. Is that right? These two solutions differ by pi. They're in opposite quadrants. We have seen this over and over, and we've talked about it. Those are in opposite quadrants. Now, once you get the general solution, what do? Do your what? Sequential solution, yes. 5 pi over 6 plus what? N pi, okay? You're going to write the general solution to the sequential solution. How do you do that? Multiply with the top by 6, divide the bottom by 6. Okay? So you're going to go through that process. 5 pi over 6 plus 6n pi over 6. What do you guys do now here? Factor out your what? Pi over what? 6. And what do you end up when you factor out pi over 6? T will be what? Pi over 6 times 5 plus 6n. This is the sequential solution here. Okay? So this one's going to be done a little bit different. But what do you need to remember? Anybody remember what do I have to do? What do we really need to remember? This is for t. What's the story? T is really 3 theta, isn't that right? So if t is really 3 theta, what do you have to do? Don't forget. T equals 3 what? Theta. So we need our solution in terms of what? Theta. Remember, use that piece of logic I gave you. This means now that 3 theta will be pi over 6, 5 plus 6n. So when you solve for theta now, because the solutions are in terms of theta, divide what? Both sides by 3, and your arithmetic will be a little bit easier because now you have pi over 6, 5 plus 6n divided by 3, which will really be 5 plus 6n times 1/3. Is that right? Okay? Now, I want you guys to remember, how do you multiply these fractions here? I got a fraction here, a fraction here. What do you do to do that? I know you got to switch the order, but that's going to be now what? 6 times 3 is 18. 5 plus what? 6n. So, ladies and gentlemen, pi over 18, 5 plus 6n. There it is. This is your sequential form for theta. Your sequential solution for theta. Because the original question wants solutions from 0 to what? 2 pi. You can now generate your what? Your solutions and see if they're in the interval from 0 to 2 pi. So this is what you do now. So how do you start that process again? Do you guys remember? Start with n equals 0. And if n is 0, what do you guys get with theta? Right? Plug in 0 over here. 6 times 0 is 0. Then you get that 5. You get theta will be what? 5 pi over 18. What happens when n equals 1? Plug in now what? Over here. 1. What do you get for theta now? What's 6 times 1? Right? Isn't that 6? What's 6 plus 5? 11. So it'll be 11 pi over 18. That ratio is still You say, what do you mean? Isn't this ratio still what? Smaller than 2, 11/18? Once it gets bigger than 24, that's where you stop. N equals 2. So plug in now a what? A 2. What's 6 times 2? Is that 12? What's 12 plus 5? 17. So this answer is going to be what? 17 pi over what? 18. And then now, what's the next value for n? You say n will be what? N is 3. All right. So theta is going to be now, plug in 3 here. Do your arithmetic. What's 6 times 3 now? Is that 18? What's 18 plus 5? So it's 23 pi over 18. N equals what? 4. So plug in your 4 now. 6 times 4 is what? 24 plus 5 is what? This is 29 over 18. N is what now? 5. What happens when you plug in 5? What's 6 times 5? Is that 30? What's 30 plus 5? 35? So your theta is going to be now what? 35 pi over 18. Are we close? When do we stop? Should we stop already? 35 pi over 18? Our solutions have to be between 0 and 2 pi. So 35 divided by 18, I'm going to say to you guys, that's less than 2. It's 1.944. So I want to remark, we probably have how many more to go? Only what? 1 more. So n will be 6 now. And plug in 6 here. So do your arithmetic. 6 times 6 is 36. What's 36 plus 5? 41. You say, oh, no, this is 41 pi over what? What do you guys know about that? Is 41 over 18, isn't that ratio bigger than what? 2? How do you know it's bigger than 2? Because anything larger than 36 would be bigger than 2. And so that factor of pi is still there. What I'm saying to you guys is your solutions that they gave you here is restricted, 0 to 2 pi. So you're going to have to go through and find every one of those solutions by using that sequential form. This is a more efficient way of doing things. This is why you want to invest in that sequential form from already writing it in general form. And that's all the detail, ladies and gentlemen. What do you guys think? These are your solutions. Easy peasy lemon squeezy? All right, pretty good. All righty. I'm just looking here. For one, would they say cosine theta over 2 minus 1 equals 0. You go, well, what happens here with these multiple angles here? This is not just theta. So you go, is that still multiple angles? Yes. It's not theta, so let's let what? let's change it now. Let's let t now be theta over 2. And so you say, does that give me what? Cosine t minus 1 equals 0? And it sure does.
So essentially, doesn't matter what number is inside the parentheses, just turn it to.
You're going to substitute. If it's not theta or just x by itself, then substitute. And now we can solve for cosine by adding 1 to both sides. So now you'll get that cosine t being what? 1. Okay, now I'm gonna again preface this by saying they're gonna give us a restricted domain for theta. I didn't write it down. Maybe let's move this and write it down. But I want to go through that process of showing you guys how to get these solutions in a restricted domain. Now, you might say, what is t? If cosine t is 1, do you guys remember? What does t have to be? Anybody remember graphing cosine? Do you guys remember graphing cosine? I know I do. 1, what else? -1. Cosine starts up here. What does it do? It goes down, doesn't it start? At a max. Do you guys remember graphing this? You say, why did you graph it? Well, because now I know something about t. What does t have to be? T is going to be what? 0. T is going to be what? 2 pi. Is that true? Because this is where cosine is 1, 0, and 2 pi. If I bring in, even though I don't need to, if I brought in all students take calculus, zero and 2 pi, you go, here's the first solution, 0. It's also the what? Second solution. Would you guys agree? You guys see my point? So in general, what do we say? What's the general solution? T is actually what? 0 plus what? 2n pi? You say, why do I say 0 plus 2n pi? Because I got to get every coterminal solution. That's how we describe n revolutions. N revolutions in either direction, in the positive direction and in the negative direction. So here's the general form. T is simply what? 2n pi, and yes, n is an integer. We know that by now. So you go, oh, I get it. There you go. T is n pi. This is also the sequential solution. So you go, how is that so easily the sequential solution? Well, it's both. It's general, and it is what? Sequential. What do you do now, ladies and gentlemen? Anybody remember, what do we do now? They don't want solutions for what? T. They want solutions for theta. And they want them between 0 and 2 pi. So if T is theta over 2, you want to bring that down and say, we know something here. T is what? Theta over 2. T here, T here. What does that mean about your theta? Logically speaking, right? You guys want the colors? We'll show you the colors. Logically speaking, theta over 2 is 2 in pi. Could you guys solve for theta? How do you guys solve for theta? Multiply both sides by 2, and now you get theta canceling. So now theta would be what here? Theta is 4 in pi. So if you said, how do I get my solutions from 0 to 2 pi? Well, let n be 0. Can you tell me what theta becomes? Right? If n is 0, what is theta? Isn't theta 0? Okay. Let n be 1. What is theta now? So you say, can I change n? Yes. What's 4? 4 times 1 is 4. So that means theta is what? 4 pi. What's the problem? Already it's bigger than what? Than 2 pi. So we got to get rid of this. We got to get rid of this. And then, ladies and gentlemen, our theta is what? 0 degrees. Theta is what? 0. So, since theta is 0 here, they restricted the domain. There's only one solution. That's 0. Okay? But they might say something like this. They might say this to you. Like, notice the language in your book. The language in the book simply says this. Find all what? Solutions. What are all solutions? What do you think they mean by that? All solutions is code for the what? General solution. So here, you'd be done right here. Sorry, where's theta? So in other words, you're right here. You're done right here. You wouldn't need to start looking for particular solutions. You're done. This is how you generate really all solutions. And they're really just multiples of what? God, I'm trying to get a highlighter. 4 in pi. Yeah, 0, they might do something like this. 4 pi, what else? 8 pi, that's n is 2. N is 3 would be what? 12 pi, and they put these 3 dots. You say, what does that mean? Goes on forever? They might even say, what about -1? I got negative 4 pi. They might put a negative 4 pi. N is -2. Negative 8 pi. N is -3. Negative 12 pi. They'll put all of these here as well. And then like together, all together in back of the book, you might see 0, and then they say plus or minus what? 4 pi, plus or minus 8 pi, plus or minus 12 pi. They actually give you your answer this way, and this way is another way of describing a sequence. This is still a sequence of solutions. So you have sequences of solutions, and that kind of, you might look in back of the book, and you go, oh, they did this? This is all the solutions? Yeah, it's in the form of a sequence. It's a different way of writing a sequence. This is the formula for the sequence. And you say, well, what is n? A lot of times, you're going to have to describe n as a what? is in this set is an integer. So that's what that even means. N is an integer here, these symbols. So that's why you see it defined that way. And then you might even see in back of the book that the author just puts it, uses the n values and lists this as a sequence. This is another sequence. This is it, you know. One's implied and one is explicit. One's implicit, the other is explicit. All right, ladies and gentlemen, you guys see this here? Okay, give you another example here. Sine maybe x over 3 equals cosine x over 3. Okay, and this is again find all solutions. So you may notice already again from the beginning here, right? You say, wait a minute. X over 3, x over 3. Okay, you're going to let that be what? T. T. Yeah, let T, wherever you see the x over 3, you're going to switch that to T from the beginning. You go, okay. Do your substitution. So that now gives you what you have here. Sine t equals what? Cosine t. So now you are in the mode of what you did before. You might say, what did you guys do before? How did you solve this before? Do you guys remember? Because I gave this to you guys before. Divide both sides by what? Cosine. And on the left, you have sine over what? Cosine. What does that equal? 1. What's the ratio of sine over cosine? Tangent equals what? So this is what you guys have already seen. Tangent is 1, and it's positive already. So you don't need a reference angle. Opposite over adjacent's 1. What's your special triangle? Isn't that the 45, 45, 90? What's your angle T? Pi over what? 4. Pi over 4, 45 degrees. Okay, you guys okay with that? Sine over cosine. So it's 45 degrees. Now, since it's 45 degrees, that's your quadrant 1 answer. That's also your reference angle. All students take what? Tangent's positive in what quadrants? 1. 1 and what? 3. Okay, you guys okay with that? So when you write the general solution, because they want all solutions, you say, okay, pi over 4 plus what? You guys remember this? They're in exactly opposite quadrants. When they're exactly opposite, what do you say? Plus what? N pi. Good. N pi, ladies and gentlemen. Okay? You're almost there. So this is the general. What's your sequential? Right? So you're going to say t will be pi over 4 plus what? N pi. So multiply the bottom and top by 4. Is that true? We've seen it for a couple of days now. Pi over 4 plus 4 pi over 4. What do you guys do now here with this pi over 4? Factor it out. You might even say, but I don't see a number here. Put the 1. Okay, 1 plus 4n. Now, ladies and gentlemen, here's the story here. T becomes now what? One plus 4n. Here is your what? The sequential form, but you're not done. You say, why aren't you done? What is t? Is it x over 3? So you're going to have to put this now. Remember that they want you to solve for x, theta, x, whatever. T is x over 3. T. Okay, now what does that mean even? X over 3 becomes what? Pi over 4. 1 plus what? 4n. Multiply both sides by what? 3. What does that mean about x? X will be now what? 3 pi over 4. 1 plus 4n. So this is the sequential form in terms of the variable x, which is what they're looking for. And this is going to be able to generate all your what? Solutions here. So, if you want to take a look at all solutions, you can say, well, I'm going to let n be 0 and see what x is, right? N is 0. Back up here. Oh, x is just 3 pi over what? 4. Okay. N is 1 now. All right. 4 times 1 is 4 plus 1, that's 5. So x will be what? 5 pi over 4. Now n will be 2. Four times 2 is 8. 8 plus 1 is 9. 9 times 3. Oops, I'm sorry. That's 15 pi. Right? 15 pi over 4, because that's 5 times 3. So now 8 plus 1 is 9. 9 times 3 is 27 pi over 4. Anyway. There might not be a nice pattern like the last one. Now try negative 1 here, right? So let's try that. I might even say, okay, let's do n is negative 1. So let's look at these solutions. Negative 1 times 4 is negative 4 plus that's negative 3. It's negative 9 pi over what? 4. N is negative 2. Plug in the negative 2 now. 4 times negative 2 is negative 8, plus 1 is negative 7. Is that right? Negative 7 times 3 is negative 21 pi over 4. So just going to kind of share with you guys, I guess, what you can see in back of the book. So, what I notice is whoever did the solutions for this textbook, for this section, is not very consistent.
Yeah.
And, that's unfortunate. Okay? It's very unfortunate. So here's a way that you might see the answers in back. They put the sequential form. They might even put the what? General form. Where is it somewhere? Here. They may even do this. They may start to list these solutions. They may say, oh, here's the solutions. 3 pi over 4, 15 pi over 4, 27 pi over 4, comma, with all these dots. They might even put negative 9 pi over 4, okay? Negative, 21 pi over 4. And put these dots as well. That's what you might even see, because I know they sometimes do that. And these 3 dots mean, really, they mean to continue the pattern forever. And you continue the pattern forever because what do you guys know about n? N is a what? Integer. And that's why you always see that phrase there, n as an integer here. So they can give you the general solution, sequential solution in back of the book. They can even start listing particular solutions with this 3 dots saying continue this pattern forever, even though they didn't even write down what the pattern was. And you go, wait a minute, they didn't tell me what the pattern was. They're just listing these things. I know. And the bad part about the book in that way, whoever did the solutions, is they weren't consistent. And I find that the consistency is key with students. Try to be consistent. Because when you're learning this, you're like, what? You got to, if you try to make people piece together everything, it's not always a good thing. And go back here just to kind of emphasize, remember, t is x over 3, right? And I started to talk about the general solution. The general solution was up here. So you could see here in back of the book, they do the substitution here. So you go, oh, are they going to give me now what? X over 3 will be pi over 4 plus what? N pi. Well, yeah, solve for x by multiplying both sides by 3. You now get x equal to 3 pi over 4 now, plus, if you distribute that 3n pi. And you go, where did they get this general solution? Well, that's what they did. Okay, that's what they did. This is a general solution. They did already the substitution in the beginning. Now, sequential form, you can even still do the sequential form here. It's equivalent. I was doing that in my head. Even when you said, what if at this point I did sequential form? Well, you can. Let me do this. Meaning you multiply the bottom and top by 4. You'll get that 3 pi over 4 here plus 12n pi over 4. And, this is going to be equivalent. So you go, okay, pi over 4, I'm going to do the thing that we've been doing. So you get your pi over 4 again, 3 plus 12n. You go, but Mr. Judge, that does not. Oops. Yeah, there it is down there, sorry. You say, but Mr. Judge, that does not look like the one you just did here. You did earlier. You got this one. What's going on? Well, they factored out the what? That 3. 3 goes into 12. It's going to be the same thing. So this is what you get. This is why I do it at the end. 3 pi over 4, factoring out that 3 is 1 plus 4n. And that's exactly what we did here. So they're match. So just to let you guys know, just do it the way I showed you originally and, get the sequential form from the beginning. But, if you see this in back of the book, the general solution, that's where it came from. So I would just say do it as we've been doing, write this get the general form and then the sequential form and then convert the variable back to where it was. Just exactly how we've been doing, just so you guys know. Anyway, ladies and gentlemen, there it is. Are you guys better able to do your homework now with this section? What do you think? Okay, we'll see you guys tomorrow. Take care, stay safe. Have a wonderful day.